Welcome back. I hope you enjoyed that video. I think she did a great job of describing how the Monty Hall problem. So, I had asked you to think about empiricism and rationalism. Rationalism's logic, if you'll remember, and empiricism is direct observation. And I had asked you, I told you that she solves the problem two ways, with rationalism and empiricism. And I had asked you to identify when she uses each of those ways. So now I hope you were able to do it yourselves, but now I'm going to tell you. Okay, so rationalism and empiricism. When I do this class live, I also solve things with rationalism and empiricism. So I'm going to start with the rationalism, the logic, which is how she described it, sort of. So she explained, and my example is going to show envelopes because when I do it, we have envelopes instead of doors. So the initial probabilities when the game starts is that the experimenter holds two envelopes, or 2/3 of the probabilities, and the participant holds one, or 1/3 of the probability. Now, when the experimenter discards the envelope, the probabilities do not change. So, when the Monty Hall reveals one door, the probabilities don't change. The probabilities are set from the beginning, and they don't change because, by the rules of the game, that envelope is empty or the door that the experimenter reveals is empty. Okay? So the probabilities don't change. So then the final probabilities, the experimenter holds 2/3 and the participant holds 1/3. They don't change. So the participant is 2/3 more likely to get the money when he or she chooses to switch envelopes. Okay, so that was using logic to figure it out. Okay. We logically figured out, by what we know about probabilities, that it's always better to switch, right? Because the experimenter always holds more probabilities. So when the participant switches, the participant holds more probabilities. Or just another way of doing it, when the dollar bill is placed into the envelope, the probability of choosing it from each envelope is fixed at 1/3. 1/3 plus 1/3 plus 1/3 equals 100% chance of choosing the money. So the participant has 1/3, the experimenter has 2/3, because the experimenter has two envelopes or two doors, depending on which way we're doing the experiment. But when the experimenter gets rid of the envelope without the money, the probabilities don't change. And that's because the experimenter knows which one is empty, and they're always getting rid of the empty envelope. So the probability from the empty envelope changes to the one that the experimenter still holds. Or in the door, which is the exact same thing, when the experimenter opens the empty door, the probabilities change to the door that's still closed. So because the probabilities are fixed at the beginning of the experiment, the probability from the discarded envelope or door envelope transfers to the kept envelope, because the empty one is always gotten rid of. So using that, that's rationalism. We used logic to figure it out. Now, when we hold this class in person, I had have you guys divide into groups and actually play. One of you guys is the experimenter and one of you guys is the participant. And I actually have you guys do 10 examples. We don't say the rationalism part yet. Everybody in the whole class just does a little, everybody in the 10 times. They play that game 10 times. And then we come up to the board and we count, and it always works out. The people who switch, when you switch, you're 2/3 more likely to win. So she did that by having that whole layout of doors and crossing them out and figuring out that you always win more times when you switch. So that was empiricism, the trying it out, the doing it. That was an example of empiricism. So science itself involves both rationalism and empiricism. In the first few steps of the research process is rationalism. We use logic. We use what we know from facts that we've learned from other articles, and we logically infer what we think will happen when we actually do our experiment. So that first part, that's their rationalism. Then we do the experiment. That's empiricism. That's when we actually go out in the world and we test our experiment. That's empiricism. So science involves both rationalism and empiricism. Rationalism is using logic to put what we know from past science to project or predict what's happening. That's our prediction, is our hypothesis. And then empiricism. And empiricism is actually doing it ourselves. So I'm going to go through, and by this time, this is the same thing that you saw on our last lecture. I'm going to go through the steps of the research process one more time. And I'm going to remind you which ones are rationalism and which ones are empiricism. So first we come up with an idea. And that's just imagination. Or it could be from reading through the literature. Then we do some library research. That's gathering the facts. And we observe in the real world. So our idea is kind of a combination of both things. Then we develop the idea into a testable hypothesis. And that part is rationalism. So we take what we know about the world and we logically put it together into a question that we're going to test. And that's rationalism. So we develop our idea into a testable hypothesis. And part of the tool we use in our rationalism is deductive reasoning. Then we choose an appropriate research design. So we're moving to empiricism. We're deciding how we're going to test it. We choose our subject population, again, deciding how we're going to test it. We decide on what to observe, again, deciding how we're going to test it. And then finally, we conduct our study. And that is empiricism. That's when we're going out into the real world and we're seeing if what we rationally thought was going to be true, our hypothesis, we're testing our hypothesis. Now, sometimes it doesn't work out. So that's when we go back to our idea and we might rework things a little bit. But that's when we have a little more time in the class, whether it works out or not. And I promise you, you will not be graded on if your hypothesis is proved true or not. Don't worry about that. So we're going to go, after we conduct our study, we're going to analyze our data, and that's our statistics, and that's just testing to know if our results are due to chance or not. And then we report our results. And that's just wrapping up the study after we have started out with rationalism and tested it with empiricism. So first we make an observation, then we question, and then we decide upon a hypothesis. So that hypothesis there and the process of observation and questioning, that is all rationalism in the first half of the study. Then we predict. That's part of the hypothesis. We do our experiment. That's an empiricism, and we get our result. So we've got both logic and testing in a research study, both rationalism and empiricism. That's why science is so strong, and it's held up for so many years. The scientific method involves both aspects and is a pretty good way of knowing about the world. So now I'm going to go through one more time the steps in an example I would like to call an oldie but a goodie. But it's a great example, and it's a great way to walk you one more time through the steps of the research process, because you are going to do this in class again and again. So it's an old study. There's an APA style reference for it. And it's a study that was published in 1988, probably before most of you were born, in the Journal of Personality and Social Psychology. The authors are Frank and Gilovich, and the title of the article was The Dark Side of Self and Social Perception: Black Uniforms and Aggression in Professional Sports. So these guys started with an idea, and it's an idea you might have thought of too, and some of you fashion majors might have thought of the meaning of clothing quite a bit. And the idea is that sports teams might be more aggressive when they're wearing black. Interesting idea. And they noticed by observation, maybe they were watching a professional football game, or maybe they were at a little league team game, who knows. And then they did some library research, and there are some past studies showing that that black is associated with aggression. Even if we look at our language, Black Sunday, wars are often referred to with the word black. Villains always wear black in the movies. So they got this idea from a variety of sources. And they thought, from observation, we want to see if that's true. Are sports players more aggressive when they wear black? So they used deductive reasoning, and they developed the idea into a testable hypothesis. And at this point, I usually like to stop and I ask the class, how would you guys test this? And I get all kinds of great ideas. Some people say that they would just look at the record. They would look at, let's say, the UH football team, and if they see if the team wore its white uniforms or its black uniforms in that game, and then count how many fouls they got, because that would be public record. That would be in an archive somewhere. And their hypothesis would be, during the games that the team wore black, they would have more fouls. Very, very easy hypothesis to test. Then they look at the record and test it. Other ideas would be to go and actually observe maybe a high school football game, and look at the team that's wearing black and the team that's not wearing black, and count the number of fouls for each team. That may or may not be a great idea, and we'll talk about that in a minute. But there's all kinds of ways that you could test this hypothesis. What these guys did was super creative, and then messing with an observation. They decided to show other people the clothing. So what they did is they showed a class full of students photos, or not photos. They were slides with the research with the uniforms on them, and they asked them, how aggressive do you think a team wearing this uniform is on a scale of 1 to 10? So they showed them the slides of these uniforms, and they asked people how aggressive on a scale of 1 to 10. Super easy. So, but they had a little bit of a problem here. And if you think about it, and I'm picking on football. It could be all other sports. It could be a lot of other sports. We know that sports are a way that people often get out their aggression. If you think about it, what's the problem with that? Well, if you're from the West Coast, like I am, in one particular football team comes to mind. Sorry, Raiders fans. The Raiders have always had a reputation for being super aggressive. So maybe people would look at the logos instead of the uniforms. So when the researchers thought of this design, they took out the logos. They took out the logos because that would be a confounding factor, right? So because they don't want to know people's perceptions of the logos. They want to know people's perceptions of the uniforms. So they took the uniforms, I mean, I'm sorry, they took the logos off the uniforms before they took pictures of them for the slide. Now think about what else could be confounding. What happens if the people in wearing the uniforms, the black uniforms, were bulkier, just tougher looking and bigger, and the people wearing the non-black? Well, that would be a problem too, and that would be another confounding factor, because if we've got different people in the uniforms, and people vote the black uniforms as being more aggressive, we still wouldn't know if they were voting for the color of the uniform or who was in the uniforms. So had they had the same model in all of the uniforms. That's to make sure that what we're testing, we want to know if people are voting the color of the uniform is more aggressive rather than anything else. So that's choosing an appropriate research design. And in that design, remember how I said that we want to make sure that it's our variable that's causing the result and not anything else, not any confounding factors. So in this case, that was the color. So they kept the color as isolated as possible. They choose a subject population, and we've talked about subject population before in this class with talking about babies and adults. They choose college students, which we know already that limits the generalizability a lot. They know for sure that college students think black uniforms are not more aggressive, but they have to stretch a little bit. In this case, I think not a whole lot to say that everyone thinks that black uniforms are more aggressive. They decided on what to observe and the appropriate measures. So I mentioned that already. They chose slides, pictures of the uniforms with all the confounding variables taken care of. And then they just ask people on a scale of 1 to 10, how aggressive do you think the people wearing those uniforms are? Now, they could have asked them other ways. They could have used a questionnaire of aggression. They could have just had people actually look at the real uniforms. They could have looked at drawing of uniforms. There's all kinds they could have done, but they decided to use photos and a questionnaire. And we're going to talk later on in this class about the importance of questionnaires. They conducted the study. They had everybody sit. All of the college students sit in the room with pieces of paper with numbered from, in this case, it was 1 to 25, with the scale of 1 to 10 for aggression, and they showed them 25 slides with different color combinations of uniforms. And some that were all black, some that were some black, some that were no black, etc. So they conducted the study, and that's our empiricism. They're actually testing. They analyzed the data. They made sure that the numbers were so strong that we could be pretty sure the results were not due to chance. And then they reported the results. They wrote it up into a research article that I read and told you. So, and I have this arrow here, just so you know that science, and I had a great methods teacher when I was in undergraduate, and she had a lisp. And she would always say, science is a cycle. Science is a cycle. The cycle of science. The cycle of science. So what she meant by that is that one study doesn't tell you at all. Once you've tested your construct, you find out new things. Often more questions will come up. So that arrow goes back up to the idea, like I had it in the whole model, which reminds us that one study doesn't tell us the whole story. That often, and that's the exciting part about science, often results will give us another idea, And we can test that to find out more about the world. So that's it. Thank you guys for finishing lecture 2, and I will join you very soon for lecture 3.